Hello, today I want to talk about a rectangular number. Let's get started with one dot here. One dot is number one, n equal to 1. And then I add two more dots so that I have a rectangle. So now n will be 2. So right now I'm going to have 1 plus 2. Alright? And then I add 3 more dots so that I have a rectangle like this. Right now the total number of dots is 6. So n will be, sorry, this one is 3. Okay, n is 3. And then add more 3 dots. So you're gonna have 3 plus 3, which is 6, is obtained by 1 plus 2 plus 3. And then I add 4 more dots. I will copy these 3 dots. No, this triangle, and then put 4 more dots here. So you have a rectangle. And what is the total number of dots? It's going to be 10, right? So it's going to be 1 plus 2 plus 3 plus 4. Okay? Put 5 more dots so that you have this rectangle. Then we will have 1, 1, 2, 3, 4, 5. Okay? Then it turns out to be 15. It's obtained by 1 plus 2 plus 3 plus 4 plus 5. Okay, I think you know that the next one is going to be 21 because it's obtained by 1 plus 2 plus 3 plus 4 plus 5 plus 6. And this number 6 is obtained by adding 6 more dots into the previous rectangle. So we're gonna have 1, 2, 3, 4, 5, and 6 like this. Okay, as you can see, these numbers 1, 3, 1, 3, 6, 10, 15, 21, and next you can guess 28, next plus 8, 36, next plus 9, 45. These are called triangular number. Okay, are called triangular numbers, which is a number that is obtained by adding the number of terms. Okay, so we start with 1 for the first term. In the second term you add 2, so we're gonna have 1 plus 2, which is 3. At the third term we have to add the previous term by 3, so you can have 1 plus 2 plus 3. On the fifth term you have to add the previous term by 4. Okay, so it turns out to be 10. On the fifth term you have to add the previous term by 5, so you have 15, and all the way and so on. Okay, so formally speaking, if n, a positive integer n, is said to be a triangle number, even only if this number n can be written as the sum of consecutive integers 1 plus 2 plus 3 all the way to some number, let's say k. Okay, for some integer k. Right, now I think you know an example already. So we have 1. Okay, 1 is a triangular number. Alright, and 6, why 6 is a triangular number? Because 6 is obtained by 1 plus 2 plus 3, which is the sum of consecutive number. I may choose 15. Okay, 1 plus 2 plus 3 plus 4. Now it's 10, right? Plus 5. 15 is a triangular number. And 28, which is obtained by 1 plus 2 plus 3 plus 4 plus 5 plus 6 and plus 7. Okay, this is 15 plus 6 is 21 and plus 7 is 28. Okay, these three numbers are called triangular numbers. Okay, so in the sequence, in terms of sequence, it can be written as 1 3 6 plus 4 10 plus 5 15 plus 6 21 plus 7 28 plus 9, what next, no, plus 8 36 plus 9 45 plus 10 and 55 and so on. Okay, so in general, if I let Tn to be the n term of the n the n term of triangular numbers, then Tn is going to be 1 plus 2 plus 3 all the way to n. And we know that the sum of consecutive number from 1 to n is n times n plus 1 over 2. Okay, and to have the next term, we gotta have, let's say, Tn can be obtained by Tn is obtained by Tn plus 1, okay, is obtained by the previous term, which is Tn plus sorry, I might start with Tn. Tn is going to be Tn minus 1 plus n. Okay, so Tn plus 1 is obtained by the previous term and plus n plus 1. Okay, for example, 45 is which term? 1 2 3 4 5 6 7 8 9 is the ninth term, right? T9. Okay, to have the next term, you have to add T9 by 10, so you're gonna have 45 plus 10, which is 45. Okay, the next term is T11, so you have to use the previous term and plus 11. So you're gonna have 55 plus 11, which is 66. Okay, all right, now let's take a look at this statement here. Okay, this statement. So if e is an odd integer, then e squared minus 1 over 8 is a triangular number. So let's prove this statement. So let's start with proof, and I will assume that e is an odd integer. Okay, so this means that there exists, let's say, an integer k. In this case, I will use positive integer k, such that e is 2k plus 1. Okay, 2k plus 1 integer. I think I want to use minus 1. Minus 1 is better because k starts from 1, so that you're gonna have, so e can be 1 to 1 3 5 and 7 and so on. And then let's have e squared minus 1. So e squared minus 1 will happen to this, so we're gonna have 2k minus 1 square, which is 4k square plus 4k plus 1 minus 1. So we're gonna have 4k square minus 4k. okay? And then you're gonna have 4k times what? Times let me think. I have to factorize, right? K minus 1, okay? And then I have to show that this one e squared minus 1 over 8 is a triangular number. I have to divide this equation by 8, so we're gonna have e squared minus 1 over 8. What happened is we have to multiply 1 over 8, so we could have 4k times k minus 1. Alright, then we're gonna have, what do we have here? We're gonna have k, 4 and 8 become 1 over 2, right? Times k minus 1 over 2. Okay, I think you are familiar with this, right? Because this one, this term is the formula of 1 plus 2 plus 3 plus 4 all the way to k minus 1, which is the sum of consecutive number. And a number that can be written as the sum of consecutive number is a triangular number. Alright, so we complete this proof. Hence, e squared minus 1 over 8 is a triangular number. Alright, okay, that's it for this video. Okay, and see you next video. I will have additional statement for triangular numbers. That's it for today, guys.